Now, I would like to request Dr. Jahangir Dewan sir to start his discussion on empowering high-tech economy in Bangladesh with microelectric VLSI design and ESDM.
Thank you. Assalamu alaikum, everybody. Thank you. All right. Thank you very much. Sorry for the technicals. We use usually Zoom, Microsoft. We don't use, even though it is from here. So thank you very much, Honorable Vice Chancellor of RUET, Honorable Vice Chancellor of USTC, Chief Guest, ladies and gentlemen. It is a great honor for us to talk to you today about this special topic of empowering high-tech economy in Bangladesh, an ecosystem for microchip VLSI design and ESDM. ESDM stands for Electronic System Design and Manufacturing. And then we'll be putting together a vision for VLSI Design Center of Excellence, and we call it VCOE. And my name is Dr. Jahangir Dewan. I'm from Silicon Valley, and I work in microchip design for last 20 plus years, and my company is SBIT, and we have been active in Bangladesh for supporting the universities, providing all these software and services. We created about 14 different VLSI labs in Bangladesh, in 14 different universities, just a couple of startups also. And there are hundreds of people, electrical and computer engineering graduates. They're getting job as well. Some of them, after getting training from us, they got job in Malaysia, Singapore, and Japan. Some of them, they came for higher studies to the US and Europe. Anyway, I welcome you all for my presentation. Let's see. So it came in a previous presentation from Dr. Jahangir Alam. We saw it that some of the electronic concept he was talking about, 4IR, he was talking about some of the machine learning concept, this and that. Everything is the brain behind everything is electronics. Without electronics, life is, everything is blank. You can say that. Everybody has mobile phone or any kind of devices. Now, if you look around us, what happens? We are using mobile phone, we are using some kind of TV or some other devices like laptop. Everything is made out of electronics, microchip. Even nowadays, autonomous vehicles and all these we are talking about. We are talking about data centers, we're talking about some of the other communication routers, these and that. Everything has electronics into it. Even our household, we'll be talking about, for example, getting data from your like IoT devices, monitoring your say washing machine or any other kind of refrigerators, for example, whether you have food or not. Everything will be controlled by electronics tomorrow. So now for you, since we are talking about university today, so think about the current situation, learning situation everywhere in the world. So it is going digitally. The learning pattern has been changed. The way we have been teaching yesterday, it's not going to work the same way today because of unforeseen situation like the pandemic. We see COVID-19, right? The classrooms are going to be different. The teachers' skills and expertise is going to be completely different. We have to learn new things. And multimedia classroom will play a big role. Now, why Bangladesh? The motivation behind me or some of the people like Dr. Jahangir Alam or Mr. Mizanul Rahman, who talked to you today. What is our motivation? Why we think about Bangladesh now? Even we did not think too much maybe 20 years ago. Now, think about it. The data, everything supports Bangladesh to be the most favorable place for doing ICT business. like the way garments has evolved. There are a few data you look at. I don't want to go to details about everything, but Bangladesh government has done so much into creating, for example, high-tech park. There are so many high-tech parks they have created to develop human capital and also bringing business so that people can get job. And Bangladesh, in a Gartner report, it says Bangladesh is one of the 30 outsourcing destinations in the world, of the top 30. And same thing, Goldman Sachs and JP Morgan, those are big like banks and investment community who talks about Bangladesh. They did not talk before. Now Bangladesh is on the map for IT. And of course, a lot of IT talents comes nowadays. When we see about 3 lakh about people every year comes in the IT workforce in Bangladesh. How about universities? There are more than probably nowadays, I would say, about 100 private universities, close to 100 public universities, right? And some of them are accredited, 50 IEEE accredited universities, right? We're talking about, yeah, it's a good universities. And about 30,000 graduates, engineering and IT graduates, they are coming out of the universities, which is good. And if you compare that with world here, sorry, the right side of the lower part of the graph, if you see, and top is the IT park in Bangladesh, and here on the right side on the lower part, see, even though it's very small, I don't know if I can go to the presentation mode to take it bigger. Probably that's the right thing to do. See, Forbes magazine, they talk about the most engineering graduates created by some of the countries. And Russia is number 1, and then United States after that. Russia about produces 500,000 people per year, and the United States produces about 250,000. And Iran, interestingly, is also advanced, which I never realized that. Japan and also South Korea, see that if you look at the development in ICT sector, those countries, you see, those top 10 countries, they are dominating the area. Even Ukraine, think about it. They're producing 130,000 graduates every year. So even Vietnam, even we are not nowhere close to Vietnam. They are producing 100,000. Vietnam, we thought it is going to be, it has to be during the war and everything, what happened, right? And they came out so quick. They're producing 100,000 ICT graduates every year, engineering and ICT graduates. Why we cannot produce, at least compete with Vietnam? That's the goal. That's the goal we have to have. Because nowadays, you see that after all these economic war with US and China, and also what are the other things going on, Vietnam is getting benefited, if you follow the news. And people, they talk about Bangladesh as well in the media, that those 2-3 countries, they should be benefited because of economic war between China and US. And also cost is going high in China. So what are the problems we have in Bangladesh education system? Dr. Jahangir Alam was talking about all the STEM programs and all these. We need to have that. Of course, this is related. So I'm going to focus mostly on microelectronics, I mean VLSI design. I know some of the electrical engineering graduates are here, probably. No, I don't know everybody. And one of the thing we need to look at is university microelectronics program. That is VLSI program or electronics program, how far we are compared to the recent trend in the industry, or compared to the other part of the world who is on the top 10 list. And do we have any other industry in Bangladesh, like any semiconductor industry or VLSI industry in Bangladesh is growing. It's very small, 2, 3, 4, 5 companies you can think about, right? There are manufacturing companies, of course, they can come in design. How about other companies like garments who are struggling? They're going for automation, but garments is shrinking. Some of them really thinking, I know one of the ones I work with, say Neural Semiconductor, they came out of DBL Group Garments. They invested in semiconductor. They have a design center. We trained them, and they are about 50 people, close to 50 people they have in Dhaka. So we expect this way some more should come in electronic design automation and electronic design and manufacturing sector. And of course, funding for the softwares are not cheap. It's not Microsoft editor, or it's not a free software. Softwares vendors, they make money out of it. They do put a lot of R&D on that, Cadence, Synopsys, and others. Of course, this has to be affordable by Bangladesh, and the government can play a big role on that. Private sectors and universities, of course, they get very cheap software tools, which we gave to about 14 different universities in Bangladesh. And of course, we expect RUET, Kuwait, and others, everybody should be coming to that club. So other program, what other countries did similar way. Brazil is one of the countries which is really had a lot of momentum in terms of developing ICT sector, especially in VLSI. Also, the government put together X amount of money. They worked with Cadence, and see that on the right side, they have a one-year program. They trained the trainers, pretty much. They trained X number of university professors. They opened up about 12 different training centers in Brazil and created close to 1,500 commercial IC designers and some managers in various levels, and created a incubator or a startup company around it, which was later on acquired by Motorola with $250 million. So that means the investment the government did, that was a good return. Now, here is a ecosystem roadmap we are proposing for Bangladesh with the government as well with the private sectors. So it has 5 pillars. So pillar 1 is academic education, which we are right now. Not in the beginning stage, we are in the middle stage, I would say, with about 14, 15 universities. Most of the top universities are under this academic program of VLSI. And we are talking to RUET also in the past to work together on a ICT project, high-tech park project as well. Hopefully they will come as well under that umbrella. And the quality of education is very important, because if I want to invite Intel or Broadcom or any other IBM to start open a design center in Dhaka or anywhere in Bangladesh or Rajshahi, then there has to be some convincing point, which is how many graduates you're producing, is there any people available, can we hire 500 people tomorrow? They are looking for numbers, 500, 2,000. So this is how India has grown. So they started with 20 people design center. Then they grow now, some of them has 2,000, 5,000 engineers in India, in various places like Bangalore, Hyderabad, then talking about Delhi, all those areas. And then second pillar, commercial IC design, microelectronic design centers. Once we have the people, skills with a number, and then these companies are bound to come because they look for alternative places. Like India, cost is going up, and they always look for other avenues. That's important. And then at the same time, we encourage local business who is in different areas. Their bottom line is not that good, their earning is not good, they're not making profit, but this area they can make much more profit in, say, electronics, design, services, outsourcing services, all these, encourage them to come. And that will really stimulate the local economy. And then foreign direct investment, of course, once we do for some of the groundwork, say pillar 1, 2, 3, of course, people will be interested from US and other places to invest in Bangladesh, creating, say, incubation center, doing a startup with the universities or other people, the way it has been happening in India nowadays. If you ask me 10 years ago, 15 years ago, do you like to invest in India? I would say no, it's not there. They're not there. Now the lot of investment going from US. Even NRIs, non-resident Indians, are investing in India. They're developing design centers. And then, of course, the media plays a big role. The media will be writing about the way they're writing about garments factory, good and bad. They will be, if you are doing good, they'll be writing, of course, good about Bangladeshi rise in like high-tech sectors and creating high-tech economy. Of course, they will be writing about it. And of course, we need the partnership with other vendors and fabs, processors, processing technology, fabs, and all these, and access to TSMC, say, that Taiwanese manufacturing company, and also Malaysia and other places. IMEC is one of the European ones. And of course, Bangladesh, if you design something, you can prototype it in the universities very easy. If you have Xilinx board or something, you can validate your concept as well. So now the ecosystem will have, if think about it, say you are a university professor or you are a student, from your capacity, what you can do. So you have taken a project, for example, or coursework. You can design a smaller things, say for example, A to D converters, if you know it, data converter, analog to digital converter, or a microcontroller, or a smaller component, amplifier. Some of the students here are familiar with amplifier. And that's your IP, that's called your IP, intellectual property. And you can say, you can validate your concept, and you can give it to the IP vendors. They can buy it, right? Or some people in collaboration with universities, they can develop the IPs, like other companies like us and other ones who is there in Bangladesh. And at the end, we can even develop the whole chip, and then we can send it for fabrication as well, right? So in this process, what you need infrastructure, and then you need resources, right? Which is your research assistants or other ones, right? Or students, right? Of course, technology is available, and you can do the design. So same thing happened in Brazil and Hong Kong. This is how they did it. So we don't have to reinvent the wheel. We can do it same way. So here is the Brazilian model again. The overall summary is this: Brazilian government, they spent about $7 million years ago. Maybe it is more than 10, 15 years ago. And then they had the university program, which you must have it. You need it, no matter what. Universities need it, right? We need to enrich the university programs. There is no compromise on it, right? We need to give right kind of tools and technology to our students. Otherwise, they will be lagging behind. They will not get any job. Even if they come outside for our studies, they will be struggling because others they're competing with, they're coming from India or China, they're ahead of the game. So in my case, when I came for higher studies in Canada, then Australia, US, initially I had to struggle a lot because some of the students in my class, they are coming from Bharat Electronics. They already know all those stuffs, and we did not have any exposure on those. You know, students coming from the universities, they already knew spice simulation and other thing. I never heard of simulation, you know, in my undergraduate. Think about it. And all the technologies we learned are older. So we have to upgrade our courses and then tailor them with the software we are providing. That's what we are doing with USTC. We are doing with RUET. We are doing with north, south, east, west, name it. Every university, they have our program. Why not RUET? Of course, you need to have it. And I appeal to the university administration, as soon as possible, you give the right tool to your students. And then phase one, Brazil, they trained X number of trainers, and they made some of the graduates are expert in VLSI design, and they create an industry. And some of the detail, I don't want to go too much technical. These are related to chip design, various steps. Now, let's talk about the ESDM market. Why I'm going to do that? Everything has some objective. Either you create a quality graduate when you teach in the university. What is the objective of the university? To create right kind of graduates that the market needs. And what is the objective of a student? First of all, to learn and also get a good job. And there has to be market for that kind of education, right? Let's look at the market. So this is worldwide market. On the top left, you see that the semiconductor sector, it has about 831 billion or 1 trillion close to nowadays market worldwide. It will be. So 2020, it is about 620, maybe it exceeds more than that, I believe now. And then it will grow. The growth is about 4% or something year-to-year growth. And think about now on the right side, as opposite to this, the Indian semiconductor market. See that India, in fact, following slide, you'll see how India started with zero, like us, $500,000 revenue first year. Then over the years, they jumped into 2015. They had a $14.5 billion just from semiconductor sector. And they're targeting in 2020, $52 billion. And I don't know how much we make from garments, but they're not interested on garments, or they cannot compete with us either way, right? And
your mic is mute. Dr. Dewan, your mic is mute. Please unmute it.
Is that, do you hear me now?
Yeah.
Okay, it was not mute. Okay, so maybe you hear me now, right? Well, hello, Dr. Alam? You hear me?
It is okay now. Okay.
Okay, thank you. Sorry about that. So the market, you see that Indian semiconductor market, the growth in 2020 is $52 billion. Now, how about Bangladesh? Bangladesh doesn't have big market. We probably have a couple of $100,000 market, or maybe 500,000 maximum. All three of us are doing. Say, for example, as Neural Semiconductor, then only 4 companies are there, semiconductor-wise. You can think about. And now altogether, probably we have close to $1 million revenue, something like that. Now, in Bangladesh, other way, if you talk about ICT sector, about 1 point, according to basis report or other reports, it's close to $1 billion earning 2017, 2018, supposed to be more, but 2018 somehow it was 748 million. And now think about it was handset import, right? And now handset import, why I'm talking about handset import and other electronics, consumer electronics in Bangladesh, see how much we are importing. And locally produced, those ones are very less. And every one of the devices has electronics into it. If we design there, and some of the electronics can get into those devices for sure. So there is a big gap between our import as well as what we are producing in electronics sector in Bangladesh. Now think about in India now, how they came to that level. So what government of India, Department of Electronics and Information Technology, what they did is they put together a fund to develop this ESDM sector, electronic design and manufacturing, in one sense VLSI sector. And for how many years they are producing some graduates. Under this umbrella, they took a X number of universities and to bring some of the programs and create X number of graduates. This slide gives you how many of them. So here is what the data I have. First 5-6 years, they have produced X number of graduates in, say, for example, in type 1, type 2, type 3. Type 1 is the PhD program in electronics and VLSI, and type 2 and type 3, those are mainly master's program, MTech program in electronics, VLSI, and bachelor degree program. So every year, they are producing X number. You can see the sums, so 3,000 to start with. Then eventually, I think now India is producing close to 50,000 graduates only in electronics and VLSI. Every year, 50,000. And the market demand nowadays is 1 lakh. So there is a supply and demand gap in India itself. So because so many industries are there, they need like 1 lakh people every year, 100,000. So also they have some of the magazines and all other things. They are talking about their growth in industry. They write papers, right? White papers and all these. And they are promoting the Indian semiconductor sectors. There are Indian also organizations like Semiconductor Industry Association or other organizations. Universities has their also another organization, society, Indian Semiconductor Society. Those ones are there, which we are trying to start. Hopefully, we will get news very soon that we are talking to Dr. Harun Rashid. We are going to establish Semiconductor Industry Association, or the other one, which is in Bangladesh Semiconductor Society, those kind of things, to promote this sector and bring everybody part of it. All the universities, all the electronic companies, they will be part of it, so that we have a voice. We have one voice to say to the government and doing the lobbying. So I already talked about it, how the growth has happened in Indian VLSI sector. It's a quick snapshot of market in how they did. They did about, say, 2015, they did 9 billion, and now they are doing more than 20 billion. And their cumulative growth is about, say, 15 to 20% every year. So CAGR, cumulative average growth rate, is 17.7% in India in semiconductor sector, which is very high, even higher than USA. USA only 3 to 4%. India is making close to 20% growth, the high growth area. So now Bangladesh has tremendous opportunity, of course, like the way they did in government sector. If we are serious about it, if government is serious about it, and I hope they're serious, and they are taking some steps, even though we need to be really quick, prompt, and we need to put the dollar in right place. So in summary, what Bangladesh has is a growing engineering education, right? 30,000 close to engineering graduates coming out of this school, and a lot of available talents. I interview, I ask people, I talk to them. A lot of them has a lot of interest, and some of our graduates, they, after taking 1 year training, they landed jobs in overseas. That means they're really good. We just having a Bangladeshi degree, we could not dream of getting a job outside Bangladesh. Now our people, we are proud that our students are getting that. They are getting directly hired by the multinational companies from Japan or Korea or from US, even from US, believe me. Because as long as you can speak to their language, I mean, your English skill is very good, you know the technical terms, you have used all the Cadence tool, for example, and nobody can stop you. You can get job, and they will give you a job. And most importantly, Bangladesh having the strategic location beside India, always companies can think about what is the next door. We are at the next door. We are at their backyard. So pretty much anybody will be willing to open up design center if we have the right kind of like graduates, right kind of people. We have also the environment is very important. We are giving good environment for doing business in Bangladesh. All the incentives are there. The way Singapore has done, all the tax breaks, all those are there. Then of course we'll be able to convince multinational companies to do business in Bangladesh. So good part is Bangladesh engineering education and other things. There are some of the data if you want to look at online available in SID data, where you can see that where Bangladesh lies. Even though we are not one of the top, but Bangladesh think about in terms of quality of education in within top 20, I would say, on the developing countries, right? On the like we are middle income country now, right? The growing engineering education compared to others, we are lagging behind Vietnam, we are lagging behind Indonesia, Malaysia, Singapore, of course, India, of course. India see within top quality of education, Malaysia is better, according to the report, then India is third, and then Indonesia, then Bangladesh lies a lot behind. So we need to improve a lot, even though we are just next to Russia, right? And we are doing better than, yeah, of course, we should be proud that we are better than of some of the other countries. I would be very much proud we are even ahead of India, ahead of Malaysia. Malaysians used to come to Bangladesh for higher studies when I was a student. Now we are going there for studies. Think about the trend has changed, right? And government has done a great job in sending their graduates to overseas, developing universities, their curriculum, their research, which we need. Even though we started late, now we need to like jump start. And of course, other data you already know. So, all right. So cost is another, Bangladesh can be most, if not the lowest, we could be very much competitive compared to any other country like Vietnam or China or other places in the Asia. So what do you do to get these opportunities to tap into? There are six I's, I would say. Initiate, invest, improvise, incubate, innovate, and then industry. What I mean like that, by that. So we have to initiate the way we're doing. Universities or other companies, they have to take some initiative, positive initiative to do something. Even start with 2 people. One of my friends started with 2 people 10 years ago. Now he has 100 people in microchip design, and I was able to help him with a project, giving 20 people project from US. And now over the time he has really grown. Same way Neural has grown from 2 people to 50 people. So for getting anything done is the best thing to start today. Then invest on it, little investment, from money from parents, money from anybody, like start it, right? Learn things. And improvise means you do it. Say, for example, a songwriter or someone, a composer, right? What he does, on the fly, he starts doing it, writing the song and performs, right? Same thing, the chip design. Don't even wait. Don't be afraid of failing. whatever it means you have, with that you do it today. Say RUET has some of the labs or some other things, they can start the VLSI lab today without even looking back what happened tomorrow yesterday, that we are behind on all these. We start today and create our graduates, make them ready. Then incubation, around it we do incubate 2-3 students, they can start incubation in the university. Incubate means they can start their own startup, right? And government has funding or incubation funding, you can ask for it, you can apply for it. And innovation, of course, is always there. Professors and students like Professor Harun Rashid at RUET and others, they're already doing some innovative work, and they got some funding from World Bank, hackathon or somewhere, and those guys are doing it. And overall, everything boils down to the industry, and we can create the innovation, and entrepreneurship creates the industry. And Bangladesh has the history of doing that. First garments factory started in Kalurghat in Chittagong, and see how it has exploded all over the country. Similar thing can happen in next 20 years. Even if we are not there, our next generation will see it. Okay, I already went through all these details. Now we are talking about the objective of the design center. We are talking about the center of excellence, right? So let me skip these. So there are multiple phases we can discuss further if you are interested in, and how we can create values. We can create the ready engineers out there, and identify engineering institutes first, who are the main players. We can take a club of 20 universities under this umbrella. If government we are talking about, with them about implementing such a project, or the UGC, I submitted a project about 20 or 30 universities bringing under this umbrella, so that we can make them ready. Not talking about 100, all of them, 20 or 30 universities under the guidance of UGC or ICT ministry, and make them ready. Set up the lab, give them media tools, and of course they need to come up with the budget. Without money, nothing happens. And then in phase 2, we talk about commercial microelectronics design center, VLSI design center. And at that time we can partner with multinational companies like Cadence and others, and we can create incubation around it. And then we can have a degree certificate program, certificate and VLSI diploma program for the graduates, so that even if they want to get a job outside, they can go. And of course, everything needs money. And then local business, once they see X number of graduates are available, they can start doing development in some of the sectors like IoT, machine learning, all those use of microchip design. Here is a vision, my vision for BD Micro, which is Bangladesh Microelectronics Design Center. What we want to start with, special manpower development with the universities. Say we want to create 1,000 graduates in next 1 year or next 3 years, like that. Similar kind of programs we are talking with ICT ministry, and I think RUET is one of the interested partner as well on that program. And then we create a government-sponsored microelectronics VLSI design center, where say 100 or 200 people will work. They will develop intellectual property, they will design chips, and it will be marketed all over. And of course, the branding will be happening in terms of made in Bangladesh, of course, and some of the chips like in automotive area, in consumer electronics, in IoT sector, in machine learning, those areas will be able to do development. What is for you in the university? Let's see. This is a special slide for the universities. I think it is moving fast. This one. So what we are talking about, I think there is an animation going on here. Okay, I will not allow to animate. So have a quick look on this one. So this is courses look familiar to you, some of the electrical engineering graduates or professors, faculties. See, you have logic design course, you have analog design or similar, right? Electronics 2, 3, 4, which I was teaching in the university in Bangladesh. I know I'm familiar with the courses. And if you don't have, we'll be helping you to develop those courses. And the red marks or these ones are going to be mainly driven by the tools. All the practicals are not anymore you need it to be on the lab. You can do remotely. So nowadays you cannot go to the classes because of pandemic. All the students will be able to run the labs remotely using VPN. So we can enable that. And we are going to, the first university will be enabling that is in Bangladesh will be USTC. I'm proud of that. I'm proud of Dr. Jahangir Alam, who is taking the initiative, and my good friend, and we'll be having remote labs, everything. It will be inaugurated probably next month. And same thing we can do for RUET. All the courses can be taught and labs can be done using remotely using Cadence tool. And students, after taking the courses, all those courses, they are part of the program, regular bachelor degree and master's program. Students will have less thing to learn. They will be learning by themselves. They'll be master, believe me. And they need it. We need to give to the students those opportunities. If we don't give them these opportunities, we'll be responsible tomorrow that we did not do a good job for them. We have to forget the past. We have to look at what we can do for them tomorrow. All right. And here are some of the universities who are already under this program. They have the software, talking about American International University of Bangladesh, talking about Hasanullah University of Science and Technology, RUET, RUET, of course, RUET will be coming. And then Dhaka University, USTC, UIU, name it. All about 13 different universities. Then some of the companies like SBIT, my company, Neural Semiconductor, Ulka Semi, Prime Silicon, those are industry partners. They already have this program. And I hope by next year, we'll have another 10, 15 universities joining under this umbrella. So students will have exciting career opportunities, as I even mentioned earlier, that they can have jobs in Bangladesh, they can have jobs in other countries. And also, if someone wants to go for higher studies, this will help. Learning from these labs, that will help. And every year, US and other countries, they hire people, especially US H-1B visa, which is now a little bit restriction, but they might be opening as well. So our graduates can get ready for that. So areas of opportunities, and there are 6 different areas in general. Students or graduates can work after graduating from the university. Analog design and of the areas where they can work, like circuit design. You already learned those stuffs in 2nd year, 3rd year, 4th year electronics courses, and you'll be learning using the Cadence tools now. And some of the designs, amplifiers, ADC, those kind of stuffs, or many other things like counters. So then digital design is mainly learning language, Verilog language, like C programming language, and implementing using verification as well as designing things. And CPU implementation, which is very hard for India, for Bangladesh. Majority of the companies in Bangladesh, they are doing mainly chip implementation work. Front end, these are called front end work. They are done mostly done in US. And some of the verification works now done in India. It's changing. India is also started doing everything, in fact. FPGA design, you can do it today even in Bangladesh. If you have the board, you can validate your concept and do it. and PCB design is dominated mostly, I would say, by Thailand, Malaysia. They are dominating in this field, not India. And tool application engineering, software mostly, software support, software development is dominated by India, Russia, Ukraine, all those countries, right? Israel is one of the most powerful players in this area, developing software support and all these. So now we want to see Bangladesh also dominating in some of the areas in next 5 to 10 years. And we need to start today. We cannot wait anymore. Now, we are partnering with Cadence in this program. Cadence heavily involved in Bangladesh. As you know, some of you might have come to Cadence SB program, and we have a global presence, and it's a big company, right? It's a Fortune 500 companies in the US, and it has its own software as well as intellectual property IPs. Here is Cadence University program. Cadence heavily invested in university program. The good news for you today is all the Cadence online courses are free for students and faculties. In the past, you had to pay, say, $2,000 per course, say any analog course or digital course, something. Now you don't have to pay any penny. So if you are Cadence customer, if you bought their tool, if RUET has their tool, RUET students, RUET faculties will be trained online, self-learning using e-learning. All the resources are available, as well as we'll be supporting them. Also, students will get the turning token, say for their students, and also peak time, say RUET, today in the lab you have say 60 students, 2 labs in parallel. You can run it. You have 30 license. Cadence is going to give you extra license to fulfill your peak demand. Those things are available. So some of the academic programs, Cadence has been successful in other countries like Brazil, India, China, Russia, Scotland, and government funded. Most of the projects are government funded. And we need to influence our government through your academic system, through your vice chancellor, through your administration, and maybe combining all the vice chancellors together, make one single body and lead the effort, and go to education ministry, go to UGC, ask them, go to ICT ministry, ask them that this program has success in other countries. If India can be successful, we are next to them, why we cannot be successful? And we have proven that in garment sector and maybe other sectors, pharmaceutical sectors. Why we cannot do that? Because of lack of awareness, I would say, lack of providing the tools and technology to our bright kids, right? We did not give them. If you did not give the right kind of protein or right kind of food to your son or daughter, right? How do you expect that he will be 5.5 feet tall? He'll be down like 4.5 feet, 5 feet, right? In general, it's a joke that in general Bangladeshis are shorter because we had lack of proteins, maybe, right? That's what Pakistani says. It's a joke, right? So we need to give right kind of proteins to our students to develop their skills in VLSI, in IT sector, so that they learn all these things, as well as the tomorrow's technology or today's technology, machine learning, AI, IoT, 4IR related technology, they can work on, they can use this. So here is a video. I would, I don't know whether I can do it. Let me see, copy. Okay. Is the video shared or not?
We all know that spreadsheet-based analytics can be mind-numbingly time-consuming, but it also can be error-prone.
Dr. Alam, can
And
you see the
yes,
video?
absolutely not efficient. But what if we could teach a machine to do our analytics for us? What
Yeah.
if we could mix in our love or lack thereof of spreadsheet analysis for PPA, TAT, and CPU training runs too? Oh, wait, we can do all of this and more. Hi, I'm Amelia Dalton, host of Chalk Talk. We are talking about one of my favorite EE topics today, machine learning. And not just any machine learning, oh no, how we can tackle our digital implementation woes with innovative machine learning techniques. Rod Metcalf from Cadence Design Systems joins me today, and we walk through how you can use machine learning to improve a variety of digital challenges in your next system design. And before we get started, don't forget to click that link. There you can find even more information about how digital implementation challenges can be solved with innovative machine learning techniques. Hi, Rod. Thank you so much for joining me.
No problem. Very nice to be here.
Okay, so Rod, artificial intelligence and machine learning are super popular topics these days, but machine learning isn't really new, right?
No, absolutely not. And although there's a lot of attention with the subject today, it's certainly not new. And one of the quotes I like is back in 1959 from Arthur Samuel, who was one of the original researchers into machine learning. And he really tried to define the term, which I think is very applicable for what we're talking about today. So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And it's the explicitly programmed that's very useful for EDA, because it's very difficult to guess every single combination of events in a typical EDA design cycle. So giving the software the ability to learn is very, very powerful. So a lot has changed since 1959 over the past 60 years. And a number of things have come together to make machine learning much more practical today. First of all, the computer science has come on a lot. We have neural network science, big data, deep learning, lots of different terms. That computer science was essential to make machine learning effective. And also, the sheer amount of compute power we have today is
Difference between these three.
Yeah, there's a learning through experimentation rather than being specifically trained. So all these three topics are relevant, but built into the tools themselves. From a user perspective, you don't really see very much. You do a bit of training, you run the flow, hopefully you get better results. That's the intention.
Okay.
So that's pretty transparent to a user. On the other hand, the outside machine learning, this is much more involving the user in the flow. This is where we start looking at the flow, we learn through iteration, we learn how to do a design from RTL to GDS more efficiently. So here the user is very involved in the process.
Okay.
And finally, it's analytics. And the intention here is to gather data from the design itself over many iterations and then start providing the user with information on things through analytics that we're finding about the design that could be improved. And so we're able to look at this vast amount of data and then come up with guidance and recommendations. Okay, that's a good place to start. So what we've done in Cadence is taken the place and route environment in Novus, and we started adding some machine learning capabilities to that. And one of the problems we wanted to research was the concern of predicting timing through the implementation flow.
Okay.
Now, if we start at the beginning, early on in the flow, we need to have something that's very quick, is run very often during placement and optimization. So here we're trying to predict timing in a very runtime efficient way. But it has to be accurate enough to actually predict what's going to happen later on in the flow.
Right.
Now, later on in the flow, we do the final routing, we do more optimization. Here we have vast amounts of...
Here it is the RTL to GDS flow, the way our students, if you are fourth year students or someone, you might know there is a tool called Innovus, which we are using in design space in Cadence, or most of the industries like Intel or IBM, anybody will be using this kind of tools, starting from RTL to all the way to GDS out. Like after that, there will be GDS out. After optimization, it goes to the fab after that. So
model at the beginning is very fast. in the improvements in the final results get significantly better. Because now we've trained the machine on the customer design and it's learned how to do that customer design better. And it's training based on the customer design that's important. For example, if you create the training model on a 7 nanometer process node, it's not going to work very well on 28 nanometers because they're completely different. So the beauty of this technology is you're training it on the design you're actually going to do, not some hypothetical case.
Right. So, Rod, what kind of results would we see in a typical application?
We've had a number of customers using this already.
So this is built in inside the tool, inside the software. Tool means software. So machine learning data is inside the tool. And that's called, so inference engine, there is a training engine, inference engine that's built. It learns from the real data coming out of the design, out of the fab, for example. And the tool use that to really meet the design timing. We say timing means speed and other things. Say we have a, say 2 gigahertz speed we need to meet. How do I meet timing in the design? Those are too technical. I don't know if how many people are technical here. So just I would like to just give a flavor or idea how machine learning or AI technique is being used in every area in software, hardware design, right? Especially in semiconductor area where software is becoming much more practical compared to otherwise the yield or chip will be failing. Say for example, think about the chip that is gone to say Tesla autonomous vehicle, right? Whether the chip is going to failing at the 200 degree or 500 degree temperature burning, right? Or it is going to be like failing in say in Alaska, for example, is minus 30 degree temperature. Those are real-time situations. We cannot always test it, but machine learning data, right, will allow us to test it and validate it. So there are so many other concepts. You feel free to see that in Cadence website. Here is the link. I can send you the link. Anyway, I'm coming back to my presentation. At the end of the presentation here is, in summary, what we talk about today. What is the takeaway for you today as RUET or others like guest, right? So Cadence and SBIT, we are working together and we already have created the momentum in Bangladesh by developing the university and developing a small market for VLSI. And we need to like move on, and we need to bring RUET and others to RUET, Kuwait, and also other private public universities who has the electrical engineering program. Almost, I think many of the ones they have electrical engineering or computer engineering program. We need to bring everybody under the umbrella, right? Of course, we need the support from Bangladesh government and the Institution of Engineers, of course, because they are accrediting body. We need to talk to them that without these electrical engineering graduates cannot, programs cannot be accredited. Simple. In US, they don't do that unless you have the proper programs, electronics program or any other program. If your lab is not adequate, they will not accredit that university. That's important, right? And then develop the high-tech economy in terms of academic incubation, in terms of developing industry, inviting multinational companies to come in Bangladesh, start another Silicon Valley over there. And this revolutionary changes has to happen. This change has to happen. The rapid transition from our say sectors like agriculture sector, other service sectors, right, to electronic design sectors has to happen, and it has to happen rapidly. And what will happen in that case? What our dream is to create a like high-tech economy, as well as Bangladesh to the is onto the developed country in X number of years. That can happen only if we are developed with the high-tech industry. Otherwise, it is going to be very, very difficult to bring Bangladesh into probably the developed country map. In conclusion, I would like to say, electronic manufacturing in many countries is becoming high cost, especially in China, even India. And the companies, they're always looking for alternative place. And Bangladesh can be their preferred destination. And of course, we need a government support and also the funding from other agencies like World Bank, JICA, and other places. We need to look into that with the government. And we need to have a target, say, for example, $1 billion semiconductor industry market over next 3 to 5 years, right? And the investment for this kind of thing is not damn cheap, is not cheap. Nothing comes out without putting some money. And of course, our government is also putting a lot of money in developing ICT sector. And this sector has to have some special attention because of our engineering schools, our engineering graduates, right? They're already there, and it could be cooked easily. They could be cooked easily with pretty much a special program, and they could be really coming to the workforce tomorrow. And let's work together and develop the semiconductor industry sectors in Bangladesh and establish the VLSI labs in various universities. And tomorrow is yours, pretty much, I would say. Thank you very much. And all the NRB engineers are ready to support you. All the non-resident Bangladeshi engineers in Silicon Valley in the US or other places, they're ready to support you. They are with you. They feel for the motherland. Thank you very much. I appreciate all of you to give me a chance to talk today. We'll talk again. Thank you. Assalamu alaikum. Again, good morning for you, or good afternoon, or good evening for you. It's almost 12:30 at night for you. My time is at around 11:30 in the morning. Thank you very much. Assalamu alaikum. All right.
Thank you, sir, for your informative discussion. There is a question from Ahmad Musa Shajib. We have skilled people, but for the limited resources, we can't make it proper implementation. We need lots of investment for the technology. Already, Walton Microtech made some electronics, but it is not sufficient. If we create the opportunity in this field, it would be revelation for us. How the opportunity can we create?
All right, it's a good question. In fact, we have some of the resources there. You don't need too much investment, in fact. There are ways to do it. For example, a startup incentives are there in terms of getting, mainly what is costing here is the license, software license cost. With the training license are available, and universities with the limited scope, they can also support some of the incubations without any cost. And then manufacturing, if you're talking about, you don't have to manufacture it, right? You'll be doing design services. And once you have, say, 4 or 5 people, for example, in other IT sector, IT area, what they're doing, students or some other people like freelancers, similar kind of freelancing thing available in the semiconductor sectors. So you don't have to worry about too much of the investment at this stage. And university softwares, the software we are giving to the universities, they are 99% discounted software. So does it answer to your question, Mr. Musa? So you are talking about also Walton and others, right? So Walton Micro made some electronics but it is not sufficient if we create opportunities in this field. Of course, Altron has to invest. Industries, they have to invest smaller scale or medium scale, and we can support them without any issue. We can create the design center, start with a small, say 10, 20 people, like the way Neural started. They started with 10, initially started with probably 10 people. Now they have grown over last 2 years, 50 people. All right, another question came from, it's not a question. Any other question?
Dear participants, it's a great opportunity for you. Working for ISS is dream for many of us, and so do microelectronics and many other fields. Please feel free to ask either by writing it down in the chat box or being unmute. We are waiting for a minute for it. You can speak in Bangla for your ease.
Yeah, আপনার বাংলায় বলতে পারেন, অসুবিধা নাই, আমি বাংলা জানি।
আসসালামু আলাইকুম
জি।
স্যার, আমি আহমদ মুসা সজীব, ইন্ডিপেন্ডেন্ট ইউনিভার্সিটি বাংলাদেশ থেকে বলছিলাম। আপনাদের পুরো প্রোগ্রামটা শুনলাম। যে সুযোগটার কথা মাত্র বললেন, এই সুযোগটা আমরা কিভাবে নিতে পারি বা এটার জন্য কি কি করতে হবে, যদি প্রসেসটা একটু ডিটেইল বলতেন।
Independent University IUB Bangladesh, right? IUB is our customer. IUB already electrical engineering এ VLSI lab আছে। তো এখানে যে সুযোগটা, আপনি কি ইলেকট্রিক্যাল ইঞ্জিনিয়ারিং এর কি ফ্যাকাল্টি অর স্টুডেন্ট?
স্যার আমি স্টুডেন্ট, 4th ইয়ার স্টুডেন্ট, ফাইনাল ইয়ার।
স্টুডেন্ট কোন ডিপার্টমেন্টে?
ইলেকট্রিক্যাল এন্ড ইলেকট্রনিক্স, ট্রিপলি ডিপার্টমেন্ট।
আপনার যে ওখানে প্রফেসর আছে আইবির, আইউবি ইলেকট্রিক্যালের হেড এখন কে? I met him once.
ডক্টর খসরু এম সালিম স্যার।
খসরু সালিম সাহেব, ইয়া। আব্দুর রাজ্জাক সাহেবের সাথে আমার পরিচয় হয়েছিল, আই ওয়াজ ইন এ সেমিনার, এবং খসরু সাহেব, ইয়া, আই হ্যাভ হিজ ফোন নাম্বার। সো ওনার সাথে কথা বলেন, হ্যাঁ, ইউ শুড টক টু হিম, যে কথা বলে এখানে কি ভিএলএসআই কোর্স তো দেওয়ার কথা 4th ইয়ারে, ইলেকট্রনিক্স এই ল্যাব কি শুরু করা হয়েছে ওখানে?
ইয়েস স্যার, ভিএলএসআই ল্যাবটা আছে। আমি
হ্যালো, আচ্ছা, না আপনি কি ভিএলএসআই ল্যাব ওখানে করেছেন? কোর্স ছিল?
জি স্যার, কোর্স আছে, কোর্স কন্টিনিউ আছে, কিন্তু আমি এখনো করি নাই। ওপেন ক্রেডিট তো স্যার নেক্সট সেমিস্টারে করব হোপফুলি।
আপনি ওখানে ল্যাব কোর্স করতে পারেন, আপনি ওই প্রফেসরের আন্ডারে প্রজেক্ট করতে পারেন। দ্যাটস দ্য আই থিংক বেস্ট স্টার্ট, রাইট? তখন ওখানে অ্যাসাইনমেন্ট থাকবে, প্রজেক্ট থাকবে, দেন ইউ লার্ন at least basic things গুলো আপনি শিখবেন। যেমন ইউআইইউ is very much successful into that. The ইউআইইউ কিন্তু অনেকগুলো ছাত্র বের করেছে last 10 years. They have been customer 10 years, and ওরাই কিন্তু বাংলাদেশে বলা যায় পায়োনিয়ার আফটার বুয়েট। যে বুয়েটের গ্রাজুয়েটরা তো বেশিরভাগ বাইরে চলে যায়, বাট ইউআইইউর গ্রাজুয়েট বিভিন্ন জায়গায় এখন আছে। আমরা হায়ার করছি, আমি ইউআইইউ থেকে বেশিরভাগ সময় হায়ার করি, because they have good program. তাদের শুধু ওইটাই না, তারপরে পাস করার পরে 6 মাসের একটা সার্টিফিকেট প্রোগ্রাম আছে ওই একই ছাত্রদের জন্য, আরো মোর ইন্টেন্সিভ ওয়েতে তাদেরকে শেখানো। তো আইইউবির সাথে আমরা ওই ব্যাপারে কাজ করতে পারি অবশ্যই। I'll talk to the head of the department to start that program, 6 months certificate program, which we are going to start with USTC as well in Chittagong. If you are interested, you will be able to take USTC course as well, probably in next few months. So that will give you, কারণ একাডেমিক কোর্সে যেটা হয় যে কোর্সগুলো তো চলতে থাকে, খুব তাড়াতাড়ি চলে যায়, ওখানে স্কোপটা থাকে লিমিটেড, কোনো প্রজেক্ট এবং ভালো করে শেখানো সবকিছু। যেহেতু ইউ আর টেকিং 4-5 কোর্সেস এট দ্য সেম টাইম, ইউ উইল বি বিজি। আর যখন 6 মাসের একটা ইন্টেন্সিভ সার্টিফিকেট করানো হয়, চাই লাইক বুট ক্যাম্প, তখন ইউ উইল লার্ন মাস মোর ইন এ rigorous way. right? So I think that will be a good thing. First, you go to the head of department and how you can use the lab. And the next semester, of course, you can take a VLSI course, then you will be learning more. Then further down, you can take a certificate course with any of the universities. If you can take even with UIU or USTC or other place, so that you are ready for the job. So invest on yourself. That's the first thing. Everything is there for you almost for free, because you are paying already for the university courses, right? And
Exactly.
certificate হয়তো কিছুটা payment আছে, but nominal. That's not too much. I think certificate course they ask about 20,000 taka or 25,000 taka for 6 months courses. Yeah. So
Thank you, sir.
that I suggest. Thank you. আর কারো প্রশ্ন আছে? অনেকের জন্য রাত হয়ে গেছে, so you need to or probably sleep. If there is no question, so I have another meeting. I have to go to the other meeting. So thank you very much. Ruet is the Honorable Vice Chancellor is here. Probably I did not see him in the list. Anyway, please send my regards. I had some email communication with him. We'll talk offline and how we can support Ruet and students will work together. Thank you very much.
Thank you, sir, and
Thank you, Dr. Jahangir Alam, for putting me. Thank you, the host.
to all of our honorable speakers and all the guests and teachers for your valuable presence. Thanks to each one of you for joining. Hope it was effective for you and will bring benefits in your future. We tried to make it helpful as much as possible, but if you find any mistakes, please excuse us. That's all. Our today's program ends here. Assalamu alaikum, everyone.
Okay, thank you, Dr. Jahangir Alam. Thank you very much, Dr. Alam.
Oh, thank you. Thank you to everybody. Well done. Well done.
All right, we'll talk next time on another topic.
Yeah, yeah.
Thank you.
Thank you very much for your invitation to all of us here. Hope to see you again.
Thank you, Jahangir Alam bhai.
Thank you, Mizan bhai. Thank you very
Thank
much.
you, Mizan bhai. Thank you, Jahangir Alam bhai. Thank you to everybody. Thank you, Ruet also.
Thank you.
Good night. Good night.
Thank you, host. Thank you, everybody. Thank you all. We'll see you again.
Thank you so much, sir.